I hope you are all doing well. On this channel, I share videos that promote the importance of mathematical modeling techniques. At the moment, I am discussing a mathematical model related to the apparent kinetic parameters of immobilized enzyme reactions. After this series concludes, I plan to introduce a new topic, the Collatz conjecture, about 1 month later. Today's video serves as a trailer for that upcoming series. The Collatz conjecture is an unsolved problem concerning an iterative calculation that begins with a natural number. If the current value is even, you divide it by 2, which decreases the value. If it is odd, you multiply it by 3 and add 1, which increases the value. The conjecture states that if you repeat this process, the sequence will eventually reach 1 for every natural number as the initial value. This conjecture was proposed about 90 years ago by the German mathematician Lothar Collatz, who came up with the idea during a break in his research. Other researchers later recognized it as a conjecture problem, and it gradually became widely known. Since then, many researchers have attempted to prove it, but it remains unresolved. I first learned about this problem online about 2 years ago and immediately began working on a proof. 1 year later, I arrived at a result I found satisfactory. I then created the figures and tables necessary for writing the paper and completed the manuscript by the end of last year. However, I later learned that mathematical papers are generally written in LaTeX format, so I hurried to learn how to use LaTeX starting in mid-January of this year and converted the manuscript into LaTeX format. This work was completed in mid-February. At that point, I paused to reflect. Throughout my career in engineering, I have written papers from both experimental and mathematical modeling perspectives. In other words, I have taken an approach quite different from the proof methods used by mathematicians. While mathematics often develops arguments using equations alone, I treated the changes in computed values as changes in experimental data, constructed a mathematical model based on observing a large number of computed values, and completed the proof. I began to wonder whether such a method would be accepted as a mathematical paper. I retired from the university 4 years ago. During my career, the number of papers I published was important for performance evaluation, but I no longer find that value system appealing. Rather than waiting through the long period required for peer review, I felt it would be better to make my work public as quickly as possible. Therefore, I decided to publish my paper on Zenodo, an open-access platform in Europe, and to upload the program used for the calculations to GitHub. In addition, to help people understand the content, I decided to explain the details of the paper on my YouTube channel, which I started after retirement. By linking these 3 elements together, I hope to convey the content of my proof more clearly. The video series on the Collatz conjecture will begin about 1 month after the current topic concludes. Please look forward to it. That is all for today's talk. I look forward to seeing you again in the next video. Take care.